Good afternoon, everyone. We welcome you all to the Maritime Innovation presentation. My name is Aishwarya Kumar, a research associate at Fraunhofer CML, and your host for today. My colleague Harisundar Mahadevan will present a very interesting topic on the subject of acquisition of simulated data with complex evaluation tasks for situational awareness in the field of scientific maritime applications. So before going ahead, one request. As this presentation will be recorded, please keep your camera and microphone turned off. Furthermore, if you have any questions about the presentation, please write them in the chat. We will try to take them up at the end of the presentation. So, Hari, if you are prepared and ready, then the floor is yours.
Thank you, Ash. Good afternoon, all. Welcome to the Maritime Innovation Update for this week. And as Ash mentioned, the topic for this week is acquisition of simulated data with complex evaluation tasks for situational awareness. This is the agenda for today. I'll briefly describe about the situational awareness and the experimental setup in example of Beyond project to evaluate the situational awareness of participants and thus testing a hypothesis. Did you know that human errors is the leading cause of maritime accidents? According to studies, as high as 75 to 96% of marine accidents have human errors as one of the causing factors. And there are like various reasons why the human errors occurs, like fatigue, overworking, lack of technical understanding, but researchers have found out that the lack of situational awareness is the predominant cause of human errors. So it's important to focus on these human factors and improve the situational awareness to improve the safety in maritime industry. So what is situational awareness? Situational awareness is defined as a good perception of surroundings and environment at all times. According to Dr. Mika, it is divided into three levels. First is the perception, where we create a mental picture of the environment using vision, hearing, and touch. Next is comprehension, understanding the combination of the real world observations that we make, the knowledge and the experience. We try to create an accurate mental picture of the environment. Next is the projection, where we predict the future and take critical decisions. And aim of a Beyond project, which is building an experience to yield optical nautical displays, is to create an evaluation tool which can evaluate the situation or the human factors, which accounts for the which accounts for the maritime accidents. So we try to evaluate the situational awareness score, and we try to test our hypothesis. And this evaluation of human factors methods can be done based on there are various situational awareness methods, or we can use an UX or in questionnaires, UI questionnaires, or we can do an workload kind of comparison like NASA TLX and RSME. And our second most aim is to build a robust, mobile and automated flexible test setup, which we can use anywhere externally. There are like many situational awareness methodologies described in literature to calculate the situational awareness of a person or a team, as mentioned here. The most popular one is the situational awareness global assessment technique, which is proposed by Ensley. Uh, we use this technique because it has high correlation with the performance. And explaining this situational awareness global assessment technique, first we try to load a scenario in the mobile bridge, and then the test person performs a ship maneuvering task, and the simulation is frozen in the pre-distant time, and questions pertaining to this situations are asked. After the freeze time elapses, the simulation continues again, and the person performs the simulation maneuvering task again for the same scenario, and the freeze happens again. And if the scenario completes, then we move on to the next scenario. And these answers are objectively evaluated to calculate the situational awareness score. The main hypothesis that we try to test are these three. First is we try to get the relation between experience and situational awareness. Uh, Experts have a better situational awareness than novice. And next is the relation between scenario difficulty and situational awareness. There is a negative relation between the scenario difficulty and situational awareness. That is like higher the difficulty, the lower is the situational awareness. And we also do and our third hypothesis is getting a relation between experience, scenario difficulty, and situational awareness. The effect of scenario difficulty on situational awareness is more pronounced in novice than experts. And to do this hypothesis testing, we do a combination with mobile simulator and our own beyond simulation awareness tool. We use this mobile simulator to create realistic scenarios with with which we can do a risk-free learning, and we get a immediate feedback. And this mobile simulator can also be moved anywhere easily, and this setup can be created very easily. We just need a mobile simulator and just a laptop to run our Beyond AC tool. The main purpose of the essay tool is to evaluate the situational awareness of the test participant in the complex scenarios in the ship handling simulators. So we create complex scenarios on SHS, and we pause scenarios at different intervals for assessment. And next is the Beyond Essay tool also has this dynamic questionnaire based on current scenarios and the participant experience. We try to dynamically generate the questions, and this also all the questions are displayed with a map for context. Moving on to the communication protocol that we use distributed interactive simulation for simulation data exchange. So this is an application level protocol with which we get the simulation data, and we process this data and we create a rule-based assessment to adhere the colrex, the collision regulation. Based on this collected data, we do this rule-based assessment, and next a dedicated interface where we dynamically display the questions alongside the scenario map, and then we evaluate the participant answers and store this result for further analysis, and we also try to get the feedback from the participants. And our experimental setup is as follows. So we have an equipment bridge which mimics the real-time ship. Uh, and we have radar, ECDIS, and VHS communication integrated to this bridge. And next is our Beyond SA tool, the situational awareness assessment, which assesses the situational awareness. And we also have an Beyond Simulation Control tool, which is an automated simulator application, which can load, freeze, and stop simulation scenarios uh, automatically based on the freeze times, predefined freeze times. So our Beyond SA tool has three major components in it. One is a chart server. This chart server has an uh, which provides all the nautical charts required for our Beyond SA tool. And next is a tracker application, which decodes the distributed interactive simulation PDU packets and track all the objects. This uh, this tracker applications works in real time, like gets a real time data from the simulator and it processes, and it also provides an Google remote PC connection, server connection to publish this real-time data, uh, to publish this assessment data. And this tracker application does the rule-based assessment as well. Next, we have the Seagull application where an user interactive map interface is there, which is integrated with the Beyond Question Control tool. Moving on to the Beyond Question Control tool, this is the UI of the Beyond Question Control tool. Based on the participant ID, novice or expert, stimulus scenario order for different combinations and freeze times are loaded, and the test person can after the test person manuals, after the freeze is done, the test person can come here and take the questionnaire. He can start and stop the questionnaire at any time. We ask three type of questions. One is a single choice, multiple choice, as well as short text answer type. Our Beyond Essay tool can evaluate all these three answers, and we store these results for our hypothesis testing. And as I explained before, we also have an Beyond Simulation Control tool. Uh, this tool uh, this tool can automatically load the exercise in the bridge, and as you can see here, it also loads the freeze time for particular scenarios, and it automatically freezes the simulator in the predefined time. And after it freezes, the user can come back to the essay tool and he can take the questionnaire. And to explain the flow diagram of our hypothesis testing process, first we try to create a complex evaluation scenarios, And next is we turn the simulation, we power on the simulator. Next, we start the simulation control beyond simulation control tool in the instructor laptop. And next is we start the beyond SA tool in the participant laptop. And then we select the participant ID in simulation control tool as well as in the SA tool. And after this, the beyond simulation tool will automatically uh, load the exercise in the bridge or the simulator based on the participant stimulus order. And now the participant starts maneuvering the ship in the SHS. And when the freeze time comes, the simulation control tool automatically freezes the simulation. And now the participant will come back to the Beyond Essay tool and he'll try to answer the questions uh, based on and our Beyond Essay tool calculates all the evaluates answers that is presented by the participant, and we store this result for further analysis. After the participant answer the questions, the Beyond Simulation Control tool will automatically start the scenario again. And now again the participant will go back to the simulator and he will maneuver the ship again, and the same process continues until it comes to the end of all the scenarios. So um, thank you for your kind attention, and I'm now open to questions.
Yeah, thank you, Hari, for a brief presentation and for providing deep insights on the topic. I think it's a great tool to evaluate the preparedness as well as the situational awareness for the navigator. And this can also help in the training process, I believe. Yeah. Now let's see if there are some questions in the chat. Hmm. I think the presentation was very clear that we do not have any questions. Okay, but anyhow, I have one question. So you mentioned the tool can upload the exercise, but how do you create exercise or scenarios, or how do you design these complex scenarios for the participants?
This complex scenarios is created across globe. We try to create various kind of real-time scenarios which we try to mimic the real ship will undergo, and and we try to this is like, say we have EMS in Baltic area, and we have a Hamburg area, and we create various scenarios. At present, we have created around 7 to 8 scenarios, and the first scenario is to train the participant so that they have a brief understanding of this testing process, and then other 7 scenarios is to evaluate uh, the hypothesis.
Okay, but I think the navigator creates those scenarios, right?
Yeah, navigator creates.
Maybe another one. So, how is this participant laptop and instructor laptop or the exercises been connected, and how this freezing thing works?
Yeah, there is like all the participant laptop and the instructor laptop are connected in a network to the bridge, and the bridge has an kind of an web server with our simulation control tool access this web server to load the exercise, and we can also and access this web server to pause and get the simulation times and all the data as well. As I mentioned here, we also use the distributed interactive simulation protocol, application level protocol, to communicate to the simulator to pause or freeze or exercise. And all this are connected in a single in a local network. And so it is very easy to replicate this network anywhere.
Thank you very much for the brief answers. Um, so if there are no further questions, I think we can bring an end to the presentation. But Hari is at your disposal if you have any questions in the future for this topic. Yeah, we appreciate and thank you for everyone's attention during the presentation today. Once again, thank you, Hari, for the wonderful presentation. And the maritime innovation will also continue next week from one of our colleagues, whose notification will be forwarded to you all by Claudia in the meantime. So until next week, I hope you all stay healthy, and we'll see you all again with another interesting maritime innovation topic next week. Thank you all for joining.